All right, so thus far we've been talking about Bronsted-Lowry acids and bases, but if you think back to Gen Chem, there's other types of acids and bases, and these are Lewis acids and bases, right? And so we're talking about Lewis acids and bases. We're talking about the electron. So Lewis acid is an electron pair acceptor, while a Lewis base is an electron pair donor. And so if we think about the conventional acid-base reaction that we're thinking about, so we'll have water interacting with HCl. And so this lone pair is going to pick up this H. The electrons are going to go onto the chlorine. Right, we know Bronsted-Lowry, guys, or wise, this is a base, this is an acid, right? The water is absorbing the H plus, so it's accepting it, so it's a base. The HCl is donating the H plus, so it's an acid. But let's think about the electron movement. If we think about this lone pair is going away to form a bond with H. So, oops, colored out the wrong color. Right, it's going away, it's being donated to the H. So this is an electron pair donor, so it's also a Lewis base, right? It's also a Lewis base. And then if we think about the electrons here, they're going from being shared to being just on the chlorine. So the chlorine is accepting the electron, so it's also a Lewis acid, right? So in this case, the definitions are the same. So every Bronsted-Lowry acid or base is also a Lewis acid or base. But we can have situations in which we're talking about the movement of lone pairs without talking about H plus. So for example, the most common one, NH3, and then BH3. These will have an acid-base reaction to form a Lewis acid-base adduct. And so we can see that the nitrogen donated the pair, so it's a Lewis base in this case, but it's not a Bronsted base because it's not accepting an H plus. And then the BH3 is a Lewis acid because it's accepting an electron pair, but it's not a Bronsted-Lowry acid because it's not donating an H plus. And so you don't have to worry about this too much. We'll touch on this later on when we get to chemical reactivity. We'll see that Lewis acids are very useful to make compounds more reactive. So I'm just going to show you this real quick. You don't really have to understand it too much. But let's say we have this double bonded oxygen here. And then we have AlCl3. One reaction that we could have is the donation of these lone pairs into this AlCl3. So this will be the base. This will be the acid. And so then what we get here is this adduct. Right, where this oxygen now has a positive charge, and we could think about drawing a resonance structure here. We could kick up the electrons here. And thus move this positive charge now onto this carbon. And so by adding this Lewis acid, what we did is we made this carbon more positive. And if it's more positive, has higher charge, it's actually going to be more reactive, right? And we'll see that later on. We won't worry about this too much for now. I just wanted to remind you about the difference between Bronsted-Lowry acids and bases and Lewis acids and bases.